Hey kids, Flexing Teacher Weber here. I hope all is well. Yesterday we looked at like terms in algebra where you're combining common variable parts and using your integer rules. Today we're going to continue using like terms, and we're going to use like terms to learn about something called the distributive property. Now the distributive property is something you've used before, you've maybe never even really realized it. Now what we're going to do is we're going to start out using the distributive property with some number facts, and then we're going to apply that to some algebra. So I want to look at this question I've put on the page here. 4 times 7. Well, you know that equals 28. Not much to talk about there, but I want you to expand your mind a bit and just open yourself up to having some creativity. Now, check this out. We could just do 4 times 7 is 28, and that's all fine and dandy like sour candy. Or, let's think of it another way. Could we think of it as 4? And instead of using the times sign, I'm going to use parentheses. 4 times 5 plus 2. Or, an even fancier way of thinking of it is, could I think of it as 4 groups of 5 plus 2? So if I expand that out, 5 plus 2, 5 plus 2, 5 plus 2, and 5 plus 2, there's 4 groups of 5 plus 2. And if I was to go and total those groups up, 5, 10, 15, 20, 2, 4, 6, 8, I still get an answer of 28, right? Now, why would I go to all that trouble? You're exactly right. If I know 4 times 7 is 28. Well, we're going to use this same idea when we're dealing with some algebra expressions in a few minutes. Now, check this out. You have control of how you do the question. Check this out. What if instead of 4 times 5 plus 2, I did 4 groups of 10 subtract 3, because 10 subtract 3 also equals 7. So if I did that, 4 groups of 10 minus 3, check that out. Let's total those groups up. 10, 20, 30, 40, negative 3, negative 6, negative 9, negative 12. And either way you slice it up, you get 28. So that's the idea of the distributive property right there. We're gonna apply that to some algebra in a couple minutes, but I want to look at another question where maybe it would be helpful to have the distributive property. Doink. So check this out. 3 times 498. Well, you could do this question like this. There's nothing wrong with this. We've learned a lot of the traditional methods of multiplying. 498 times 3. And 8 times 3 is 24. Carry the 2. 9 times 3 is 27 plus 2 is 29. Carry the 2. And 3 times 4 is 12 plus 2 is 14. Wrong with that? Perfectly fine. But what if we did this? Okay, what if we did 3 multiplied by, and I'm going to use parentheses, 3 multiplied by 500 minus 2. Because 500 minus 2 equals 498. And remember, this also means 3 groups of 500 minus 2. So let's write 3 groups of 500 minus 2. Doink. So there's 3 groups of 500 minus 2. And let's total this up. 500, 1,000, 1,500. Negative 2, negative 4, negative 6. And that works out to 1,494. So the distributive property lets us be creative and lets us have control over some seemingly challenging math questions. And it's something that we're going to need to understand when we use it to applied in some algebra expressions coming up in the next video, the sequel, the Distributive Property Part 2, Revenge of the Distributive Property. That's coming up next, kids. Flexing Teacher Weber, out.